Hello everyone, welcome to student.chem. Our present session is related to osmotic pressure. But before going to the definition about the osmotic pressure, let's have an example. The desalination of the brackish water or purification of the seawater where we are using the term osmotic pressure. Next, how can we define osmotic pressure? It is the external pressure applied on the solution to prevent osmosis is called osmotic pressure. Within brackets I wrote spontaneous process. Of course, it is also called a natural process. How can we define the term osmosis? Let's have an example. For example, we have a vessel in which we have a semi-permeable membrane which divides the entire vessel into two parts. The left hand side chamber is filled with high concentration of solvent. Nothing but that this one is diluted. The right hand side chamber consists of low concentration of solvent. Nothing but this is highly concentrated. In between we have a semi-permeable membrane. Please keep it in mind that if you wanted to produce a process called osmosis, there should be a concentration gradient. Concentration gradient in this sense, during the solution, those two chambers should have concentration gradient. One should have at low concentration, another one should have at high concentration. Nothing but this one is diluted, this one is concentrated. This one have high concentration of solvent, this one have low concentration of solvent. Diluted one, concentrated one. Through the semi-permeable membrane, the solvent molecules will flow from high concentration of solvent to the low concentration of solvent until it reaches equilibrium. And the entire process is called osmosis. During the definition of the osmosis, we are using the term equilibrium. Similarly, we are using continuously solvent molecules only flow from diluted to concentrated. Why should only solvent? Why should not solute? That depends on the fine holes on the membrane. If you consider the membrane, each membrane consists of fine holes on its surface, which consists of fine holes. Each hole size is almost similar to the size of the solvent. While coming to the solute, the size of the solute is bigger compared to the solvent. So, only solvent molecules has accessibility. That's why membrane allows solvent molecules. Next, until it reaches equilibrium, the process is continued. Coming to the term equilibrium, let's have an example. Already we know that this one is diluted. Nothing but it has more solvent molecules. For example, it has 20 solvent molecules. At the right hand side we have 10 solvent molecules. In between we have a membrane which allows only solvent molecules. During the process of osmosis, the solvent molecules flow from left hand side to the right hand side. Therefore, the solvent molecules number is decreases at left hand side, while in case of right hand side the molecule number is increases. So the number 20 is reduced to 19, 18, 17, 16, 15. Similarly, at the right hand side the molecule number is increases 11, 12, 13, 14 and 15. At this position it is having same number of solvent molecules. That is the position where the osmosis process is completed. After that, there is no flow of solvent from left hand side to the right hand side because already equilibrium is reached. But if you wanted to reverse the flow of the process from concentrated to the diluted, from right hand side to the left hand side, it requires external pressure. If you apply external pressure at the right hand side, you can reverse the movement of solvent from right hand side to the left hand side. That external pressure is called osmotic pressure. Hope it was clear. Thank you. Please subscribe student.chem.